Hey guys, welcome back to physics. In this video, you're going to learn how to interpret position time graphs. In the previous video, you learned what position time graphs are and how to create them, and now you're going to learn why they're useful. In this video, you'll be able to interpret position versus time graphs. So let's start by talking about what we can learn from a position time graph. So what I have here is a very standard graph of somebody's position as it changes over time. And the first thing that I can learn from this graph is where I started. So assuming that we start at t equals 0 at a time of 0 seconds, I know that my starting position is whatever point my line is at the y-axis at that time. So on this graph, I know that my starting position is 2 meters. I'm going to just call that equals start. And so the one thing that we can learn there then is that your y-intercept is your starting position. So if you see an equation for a line in the form y equals mx plus b, that b is your start. Next, we can also figure out our speed from this graph. So, and by speed I actually mean velocity here. So, to do that, what I want to do is I want to remind you that your speed, which I'm going to call v, is equal to your change in position, so change in s, over your change in time. So, our change in position is going to be the rise of our graph, so our change in the y-axis. And our change in time is actually going to be the run in our graph. That is the x-axis. So our velocity is going to rise, the change in our total change in position, divided by run, our change in time. You guys might recognize this as your slope. So the slope of your graph is your velocity. So if you have an equation of the form y equals mx plus b, that m is your velocity. So to summarize, from a position time graph, we can learn our starting position and we can learn our velocity. The thing to remember is the steeper your line, the faster you're going. So let's go ahead and do some examples. So let's start with example 1, which is a graph that shows the position versus time for a biker, which is going to be in blue, and for a runner, which is our line in red. So our first question is who is moving faster? And so to do that, we're going to look at which line is steeper, so which line is going up more quickly. And from the graph, we can see that our blue line is significantly steeper than our red line. So our position is increasing more quickly. Our biker's position is increasing more quickly than our runner's. So that means that the biker is moving faster. Our second question asks who starts out ahead. So to do that, instead of looking at slopes, we're going to look at our y-intercept. So the biker starts out here at 0, while our runner starts all the way up at 3. So that means that our runner starts out ahead of the biker. Our third question is asking where the biker and the runner meet. So when you see this, what you want to think about is when are their positions the same? And on the graph, that's going to be where our two lines intersect. So that'll be this point right here. So they meet at 6 meters, which is our where, but our question is asking when. And so our answer here is going to be they meet after 3 seconds. So from this graph, we've been able to figure out the relative speeds of our biker and runner. We're able to figure out who starts out ahead of the other, and we can figure out when our two different folks intersect with one another. So let's do another example. So this time we have 3 different lines to look at. We've got our biker, we've got our runner, and those are about the same. But we've also started now with a third person, a bird watcher. So, question 1, we are looking to figure out what has changed about the biker's motion. So, what has changed about the line for the biker? Remember in our first graph, the biker's position versus timeline looked kind of like this. In this graph, the new line looks like that. So the new line has a negative slope. And what that means for the biker's motion is that the biker is moving backwards. So the direction of the biker's motion has changed. So the direction has changed and the biker is now going backwards. Now we're going to figure out what has changed about the runner's motion. So remember in our previous video, the runner started at 3 and ended at 5. At 5 seconds and 8 meters, sorry there. So it started at 3 meters, ended at 8 meters. Now our biker is starting at 4 and ending all the way up at 9. So the thing that's changed about that runner's motion is that our runner has a new starting position. So they started farther ahead by 1 meter. Finally, our third question is asking what you can say about the bird watcher's motion. So let's go ahead and take a look at the bird watcher. Now the line of the bird watcher is a completely straight line. So the bird watcher's position at 0 seconds is the same as his position or her position after 5 seconds. So what we can say then is that the bird watcher is standing still. And I know this because my line, my bird watcher, is completely horizontal. So whenever you see a horizontal line, you're immediately going to think that person or that object is not moving. Their velocity is 0 and they are standing still. They're in the same spot. So that's all I've got for you. Let's talk about some takeaways. First of all, the y-intercept of a position time graph tells you where the person or object started. The slope of a position time graph tells you how quickly someone is moving. And in proper physics terminology, the slope tells you their velocity. So it tells you their speed and it tells you their direction. Finally, the direction of the position versus time graph. So that's whether it's uphill or downhill. So whether we're moving uphill, and I'll go ahead and draw what that looks like, versus downhill. So a graph like that will tell you whether someone is moving forward or backward. So that direction of that graph is going to tell you the direction of their motion. And there you have it, guys. You now know how to interpret position versus time graphs. So go ahead and try it on your own. Best of luck and happy solving.